one step further, that in the interactive tool that the student is using, there's a virtual agent that's built into that tool who is able to help them, coach them, and becomes essentially participatory media where the agent, the instructor, is built into the tool. Nik Martelaro has been working with Malta Young, who was a postdoc last year working on this, is now a assistant professor at Cornell University, and with the late Cliff Nass on this project last year. And Nik, tell us about how this social agent helps learning.
Sure. Thank you, everyone, for having me today. So when we started our project, we were basically interested in what would happen if we took some of these smart materials that we consider, simple microprocessor, some prototyping materials, LEDs, wires, resistors, and the Arduino code environment, so a pretty easy code environment for people to kind of jump in and start building physical things. They can build things, but those things, they build interaction, but what if they interacted with them? So right now, what a lot of this building looks like is this. You have a breadboard, wires, LEDs. It's actually quite small. You can build fun things. People like to make interactive devices and stuff. But the general way that people interact and build these things looks like this. I'm not going to actually have you watch about 5 minutes of someone looking through a computer, trying to read code, trying to read circuit diagrams. It's very quiet and it's a bit boring. I'll make sure my audio is up. What we were wondering, and it almost started out as a joke, but I guess some good research starts that way, is what if the robot you were building could interact with you? How come it doesn't have a say in its design? So what if the thing that's being created takes the role of the active social agent in the creative process itself? And so what we did is we actually created that. This is our prototype social agent. It's an Arduino that's interactive. We did a Wizard of Oz prototype, and it would interact with students as they learn to build basic circuits. The way it would interact is through vocal commands, and in addition, it would also it had video on the face, and it can move around. You'll notice some of the facial interactions that it would go through. And so what we did is we actually, I controlled this from a back room, and we had about 68 high school students come in and learn some basic circuitry using the Arduino. So they would actually code it, they'd actually program it. And in some cases, we would have them have the social agent be on board or off board. So in this case, this is the off board, very similar face, but it's a little device off to the side. And then the Arduino is very similar. And in another case, we have our participatory agent, which is on the device. The thing that they're building is also the thing that's interacting with them. In addition to that, what we wanted to do was look into this area of what it meant. And so that means the vocal commands would be, you would build the circuit on the board versus build the circuit on my board. So it's including itself in the design. And in addition to this, we were also looking to vary how interested the device was in the participant. And so in some cases, it wasn't very interested. The face sort of moved around randomly. It would still ask some questions, and it would still provide content. So it would teach the student how to build the circuit, along with some materials like schematics and such. But it wasn't very interested. In another case, it would ask things like, "What are you doing? Like, what are you building right now? Tell me a little more about that. That's interesting." And so we wanted to see if that would actually impact a couple of variables about student learning, namely stress, confidence, and how much they interacted with the device. So to actually go through the study, what we did is we had them do a controlled portion where they would build a simple circuit. So they made an LED light blink. This involved building a circuit with an LED, a resistor, and then programming a bit of code and modifying some variables to make it blink at different rates. And then afterwards, what we did is we actually shut the device off, and we allowed them to play with just the Arduino, and we let them build whatever they wanted. So there was sort of an uncontrolled exploratory piece of the experiment where they would just build whatever they wanted. And we actually, you can see here one example, and I'll show some more. there were some interesting things that people built and interesting things that the students actually tried to do. So overall, the setup looked like this. This is actually where, if you were a participant working with this is where you would have sat. You have the interactive device, either the onboard or the offboard. There's just a laptop, a little cheat sheet we put together with the schematics, and then the parts. So we provided everything. They could sit down and start learning. So I want to go through some of the observations that we had, and very quickly I'll probably hit some of the more, I guess, scientific data and the graphs. So perceived task stressfulness, that was something that we expected would actually be, it would be less stressful for students to have an embedded agent versus an external agent. And we did show that. You can see that, especially in the interested case, the embedded agent was, there was less perceived stressfulness. And one reason we think that is because as opposed to a teacher, an external agent asking you questions, this was more of a peer. It was almost like someone you were working with them. There wasn't as much of a risk, potentially. In addition, confidence, we showed that embedding the device actually improved the perceived confidence in people's abilities to build circuits and to actually create something. And this was manifested later on, so what I find more interesting than the graphs, is the things that students built. One student, he really liked the red eyes, and he said, I'm gonna build a dragon. I'm gonna make a dragon, and that's gonna be what he did. Other students started hooking up tons of LEDs and making them blink in different patterns. They really dove in. They really started messing with the system. Some students, they saw things, they were like, oh, this looks like a stoplight, I'll make a stoplight. Or, I don't know, I like the rainbow cloud. So people started doing all kinds of things. It was really interesting to see, and it was really interesting to see that even in about a 15-minute sort of short experiment, students could kind of get into this and start playing around and working with the tools. So one of the other things was actually that was really interesting was the amount of time spent answering the questions. So I mentioned before some of the questions that the students were being asked. For example, like, what's the most interesting thing you've ever built? Or tell me what you're doing right now. And then they would be asked a follow-up once they said something, which was, oh, interesting, tell me more. And these follow-up questions, even though they were programmatic, it didn't matter what the students said, they would spend much more time answering those questions. What I'd like to do now is actually show some examples and some video of what actually happened and what students' actual reactions were.
This looks really interesting. Can you tell me what you are building right now?
I am building a LED circuit.
That is interesting. I'd like to know more.
Okay, so current flows from high to low, and so as current flows down, it goes through the LED in one direction, and so I have to make sure to plug the longer wire into the power and the shorter to the ground.
You can make pretty much anything with electronics. What's the coolest thing you would like to work on?
I figure video games if I had to work on anything.
Cool. Tell me more.
Well, you happen to look a lot like Yes Man from a video game, so I think that's something that would definitely be cool to know how to program is a little square face. Yeah.
Would you like to know how LEDs work?
Sure.
LEDs light up when the current flows through the LED. This current excites the electrons in the LED up to a high energy state. When the electron energy drops, it releases a photon or beam of light. As long as current is flowing, the electrons jump up and down releasing light photons. Also, remember that current only flows through an LED in one direction. Make sure to plug the longer red leg into the power and the shorter black leg on the ground side. Continue building with step 3 and tell me when you finish.
Hold up. Good thing you said that, Yes Man.
So a couple of things that I'd like to highlight through that. One of them is it's really interesting. One of the most interesting things was, so a lot of the content that the device gave, for example, how LEDs work, how to wire up the circuit, a lot of these students, very little electronics experience. They learned it all basically in the 15 minutes. And the interesting thing is that one little question asking, tell me a little bit more, they were starting to walk through the process. They were walking the device itself through the circuit and actually how it works. So it was probing sort of what their thought process was. And we think we could use that in a way to actually really get students to think much deeper about what's going on and what they're building. In addition, you saw in the second clip, a student, they were being told, so one, he was talking about some of the things he's interested in video games and why he might be, you know, what actually got him interested in it. And in addition, when we told him about the LEDs, he realized, so that's when he said at the end, thanks for telling me that, he had put his LED in backwards. So we actually view this as potentially a way not only to get students to think more deeply and be more reflective about their learning, but also as a way to really deliver rich content and something that can help students, you know, really learn the subject material. So we have a couple directions we'd like to go in the future. In terms of design, we've learned a lot about how to sort of design these socially interactive devices and experiences. We're really interested to see how far we can push it. The reason I show this picture is we wonder if maybe something just like googly eyes could be enough, like the device looking at you, not even interacting, would be enough for you to think more. In addition, we're also looking into what other types of ways we can interact. And so there's verbal and then there's facial, but there could be all kinds of feedback mechanisms we can use. And in terms of research, this was a one-on-one study, so this was one student, one device, but we're quite interested, especially in my lab in the Center for Design Research, what can these devices do with teams? It's very exciting right now to see teams work together, and especially there's a lot of project-based work. What happens when this device actually becomes, in a way, a member of your team that's participating in the entire group environment? And that's something that we would like to carry forward. So thank you very much for your time.